Alright, so in this video here I'm going to show you how you can simulate dependent current sources and voltage sources. Now these are located in the analog, which is where of course our resistors and capacitors and other components are located, but they're not given necessarily a very descriptive name here. So I'm going to go ahead and just pull several of them into it. We're not going to use them all here, but it would be under analog and then E. So maybe it's going to pull in there. There we go. And then I'm going to put another one in here. F, G, and then H. So those are the four different cases we could get here. So now let's first look through these here. First off, you need to see that the left side here of these is the input. This is basically the controller here. The right side is the output. And you can kind of see, well, what kind of voltage or current source is this? Well, this is a voltage source here, and plus minus, it's expecting a voltage coming in. This is a current source, and notice the direction of the arrow, and then it's also showing the direction of the arrow here as far as for the current that would be used to determine it. So this would be a current controlled current source. Here we've got a current source on the output, a voltage source on the input, so this would be a voltage controlled current source. We've got a current coming in, a voltage, so this would be a current controlled voltage source. And now of course you can see these gains that we can set here. Those are going to literally be the numbers, like maybe it's 1.8 times Ix or something like that. So the gain would be 1.8. Now 4.30 from your text here, and let's go ahead and start getting some of this. So I'm going to delete all these things for now because we'll go back and get the correct ones. So we've got several resistors that I'm out. In fact, I'm going to just go ahead and pause the video at this point and just lay out the resistors, and then when we get ready to do the dependent sources, I'll turn the video back. Alright, and magically we're back. So I've got this set up here. I've got the resistors drawn. So my 22, 1, 4 ohm, my 40 ohm, and my 80 ohm. Now I know over here and then up here voltage source. So we're going to add those in. Well, first off, this dependent current source, if you look at your diagram, is controlled by a voltage. And the voltage it's controlled by is the voltage plus across this 1 ohm resistor. We need a voltage controlled current source. So we're going to go back to analog here, and you can see these little pictures. This is a current controlled current source. Here we go. Voltage on the input, current on the output. So I'm going to put this into my circuit, and I'm going to go ahead and mirror this horizontally. Now you have to make sure that, and it does say that my current is going down, and so you can just drag this wherever you want to. You want to keep it pretty close to the component, but this is the current that's going down. Now this is a little messy, or it can be. So this isn't too messy yet, so it just goes in right here like this. And then the voltage, well, the positive side of the voltage is over here. So I'm going to bring it down. So that's the positive side of the voltage. Now I'm going to do the negative side of the voltage. Now this is where you have to be a little bit careful when you're reading these diagrams. I'm just left clicking and on negative side. So now I was going to move R4, move this back up. Now one thing I want to point out here is notice that of course these wires are crossing right here, but there is no actual connection being made. So the diagram, because we have to just set up the circuit for the simulation. So now we need a current controlled voltage source. Now this one's going to be even more challenging to set up because voltage, what we've basically done is we've wired this up in parallel. because we know things in parallel have parallel to that 1 ohm resistor, so it's got the same voltage. Awesome. Now we need the current controlled voltage source, and that would be H here. And think about where the plugs are. So I'm going to go ahead and rotate this. I could even zoom in a little bit. You can see the plus is right here, and the minus, of course, connects over, and then the minus connects over. Now you see how it turned red there? You got to be very careful. If I were to click right now, it would make a connection there. And I'm going to hit escape for now so we can see. Okay, great. The issue we have here, we're going to have to actually delete some things from this circuit to make this work. The current is going through this 40 ohm resistor. So I've got to wire this up in series, current and same. So what I'm going to actually delete that little wire right here, and then I'm going to come down, and I'm just going to come down to that node. So that's where the current is going to start, and then I have to connect the other end up into the resistor. Now, as a side note, this is actually how you would have to measure current as well, without first breaking the circuit if you're using a DMM to directly measure current. Voltage you can measure with a DMM without breaking the circuit because you're always measuring it across a device. Alright, so now we need to set the gain. So this gain is 35, and this gain is 3.125. And now we go ahead and set up our simulation profile. Do trans for transient. And remember, we're just doing a basic DC one here, so once the simulation profile jumps up here, there's not going to be anything we're going to need to add to it. Any minute. Any minute. Something about the licensed servers on these computers at our school here that make these run, in my opinion, slow. When I run this on my computer at home, runs so much. Alright, so I clicked OK because remember at this point and we're still waiting. Wait a moment, what am I waiting? I'm waiting for nothing apparently because I wanted to make the video longer. I've set up the simulation machine. Okay. Warnings reported. It will still, I'll let it finish running the simulation. And I even mentioned this on the first video. Hopefully you can identify what I have done wrong here. You can kind of see it right here. I don't have a ground. You always have to have a, but it's still trying to simulate right now, so it's still communicating with the server here, and it will up here. This is actually the little program I use to record my videos down here. And this is, of course, the music I'm listening to. This is my email. Very exciting. Okay, we're back here. What I went ahead and did was just closed out of that simulation. Oh wait, I thought I did. Alright, now we're really back for certain. Alright, so what did I say I forgot to do here? Well, I forgot to place a ground, which is why I get all sorts of simulation problems. So I need to put my ground here and connect it up. And now I'm going to simulate, but I will again pause the video. Okay, we are back again, and you can see that my simulation has completed 100%. And now I am going to turn on my voltages, and you can see that we get the different voltages at the different nodes. Now this is where it can be somewhat challenging to read these diagrams. Oops. Is this 20 volts here? Which one is that? Well, I'm going to move it. Okay, that's pointing to this. Well, does that make sense? Yeah, that's the 20-volt power supply here. But notice that you can now figure out what the voltage that this dependent voltage source has on it, because we've got negative 20.25 on here, negative 29 over here. Taking a difference of those would get you a positive 8.7 volts for this voltage supply. But you can again turn the currents on. Now when you start turning some of these on, because we've got wires everywhere, it can be a little difficult to see where everything. So you see how I did that here, I pulled it away. And now let's look at this here. It says that there's 250 milliamps coming in, and when this says negative 250 milliamps, well, that's because it's also looking at it going in. Well, and that would make sense, right? You know, you've got current going into a node has to equal the current leaving the node, or if you're summing the currents going into a node, it's got to be 0. 250 plus negative 250 is 0. And you've got current here, and this shouldn't be too surprising, 21.414 amps, and then negative 21.14 amps. So there are currents listed all over the place, and again, it's a little bit more challenging to see these because sometimes they bunch them up all over the place, and so sometimes it's helpful to kind of shift these around a little bit to see where they are. I can't find a good spot to put that one, but we can see all of the current, and then of course we could turn power on to see the power dissipated and generated in the circuit, and that this dependent power supply up here is got a positive 185 watts, which means it's absorbing power. Dependent power supplies could be absorbing power, always delivering